Hello, welcome to Dural. My name is Mark. I've been with Dural now for 3 years. Prior to that, I was a master tiler for nearly 20 years. We're here today to talk about Dural's Durabase CI++ matting and hopefully clear up some of the confusion in the market as regards matting in general. So decoupling mats, uncoupling mats, anti-fracture mats, you will have heard many different terminologies used, but today we want to clear up some of the confusion and explain exactly why these mats are so important and how to use them correctly. So in the UK, Durabase CI++ has been sold for over 21 years, starting back in 2004. Now, exact figures are difficult to establish because of the volumes that have been used, but this decoupling mat has helped to protect everything from a small bathroom floor to international airports, many millions of square meters of tile and stone installations. So you may ask, why do we even use these mattings? So mattings like this were developed originally to replace sand. Now that sounds really unusual, but basically for hundreds, if not thousands of years, tiles and stone were laid onto compacted beds of sand. The reason for this was to isolate the tiled or stone covering from the earth beneath, because basically the earth moves, buildings move. And what we don't want is that movement to transfer through to the tiles and create cracks and broken tiles and grout joints. So this worked very well for hundreds, if not thousands of years. You can see the evidence in old Roman mosaic floors that you can see all over the world. And in places like Italy and Venice, we've got some amazing ancient marble floors which have withstood earthquakes, floods, all kinds of history. But today, obviously, building methods have changed and we tend to bond everything. So it's very thin and very easy. So today, what we tend to do is to use modern building methods. It doesn't make sense these days to cart into a site tons and tons of sand and to use these old traditional methods. It just wouldn't work in today's modern construction field. So these mattings were developed to replace that idea of sand. And the way they work is the same essentially. So today, buildings still move, the earth still shifts, and tiles will still crack and grout will still break. But by using a decoupling mat such as this, we remove that problem. We limit the risk. So how can we make sure that our matting is as good as it needs to be and as good as we claim it to be? Well, at Dural, in Germany in particular, we carry out a lot of testing, and all of this is done to internationally recognized norms. What we can next demonstrate is some of the testing that takes place to ensure that the matting functions as designed and that it is consistent and trustworthy. One important test, very important test, that is carried out on Durabase CI++ is called the Haftzug test. That's in German. In English, we would call it the pull-off test. This is a test to prove and to test the strength of the adhesion of the matting to the substrate, in this case a concrete screed. In other cases it might be a timber floor or a backer board, but it's really important to test the adhesion of the fleece, which is specially designed to be as thin as possible while still being as absorbent as possible and creating a good bond between the matting and the floor substrate. So what this test involves is a pre-prepared concrete screed slab, and these are made to specific requirements. Next, adhesive is mixed to very specific measurements, so the correct amount of adhesive, the correct amount of water is mixed for the correct amount of time. This adhesive is then applied to the screed slab using a 4mm notch trowel, but it's using the flat edge of the trowel as we would in correct installation. Then it is troweled with the notch side to create 4mm sized ribs. Matting is then applied to the screeded slab and is compressed and bedded into the adhesive properly. Next thing that happens is adhesive is applied to the matting itself, and this is pressed into the cavities using the flat side of the trowel, again as should be done correctly. More adhesive is applied, and this time is applied with the notch side of the trowel, 6mm size. Again, this is all standardized norms. And then we have some 5 by 5 centimeter mosaic tiles. And again, these are very specific tiles made just for this application, for this test. So next, these very specific 5 by 5 centimeter mosaic trowels are applied into that adhesive bed. Now these tiles are specifically made for this purpose, and it's very important that they are consistent. The tiles are then weighted with a special weight. One for each tile is applied for 30 seconds exactly, and this weight ensures that we get a very consistent bond pressure on each tile. Next thing that happens, those weights are removed, and we have to wait 28 days for that adhesive to cure fully. Now you may think 3 days is enough, and that usually is the case. We know with tiling in the UK, but 28 days allows for absolute full bond strength to be achieved, and that ensures we do everything correctly. So next we apply the pull stamp to each tile. That is bonded on with an epoxy glue, which is very fast curing but creates a very, very strong bond between the pull stamp and the tile. The next thing is a jig, a testing jig is applied over each tile, and that threads onto each pull stamp, and then a very constant and very steady pull force is applied to each tile, and at the point the tile pulls away from the substrate, we get the measurement from the test jig. How can we ensure that the quality of the matting is what it needs to be? Well, there's a number of tests which take place. So after each production run, there is batch testing. Now obviously the volume of matting that's created means that we cannot test each individual roll. Nobody can do that. But batch testing ensures that each matting is tested in a way that we have confidence in the batch. So on 10-meter tables, we unroll a mat and we check for the straightness of the mat, and we check for the evenness of the matting, and anything that is outside agreed parameters and quality controls is rejected. We're also looking for the adhesion of the fleece to make sure that's bonded correctly, as well as the mesh layer on top, which forms a very vital part of the matting. All these things have to be bonded correctly, and we ensure that that takes place. We also need to check the width and the length of the matting to make sure that that also is within agreed quality parameters, to make sure it's not too narrow, not too wide, not too long, not too short. So all this takes place and is tested again with batch testing. But it's also worth asking as well, please stay involved with our videos, ask the questions that you've got. We remain on hand in the UK as a team to answer any questions. Now it may be questions to deal with problematic substrates, issues, trying to understand what adhesives to use with our matting. We can answer all these questions, so please do ask the questions. It may be from a small bathroom floor to an architect designing a skyscraper. Please do involve us, ask the questions and put us to the test. So now you've seen some of the rigorous testing that goes into ensuring that Durabase CI++ is fit for the global tilers, the professional tilers around the world who've come to trust this product to add an extra layer of protection to their tiling installations. Thank you for watching. I really hope you've found this useful, and please do subscribe, leave comments and follow us for more useful information, because there will be much more to follow.